All right, eighth grade math students, I'm back. I know you think you got rid of me for a week, but here I am. So yesterday you guys did another activity with tracing paper, but this time you focused on rotating. And some other words that we might hear that mean the same thing as rotate are going to be spin and turn. So here are the things that we expect you guys to be able to do by the end of today's lesson and yesterday's. You guys should be able to describe how the X and Y coordinates change when you rotate. And we also expect that you guys actually be able to rotate a figure on a coordinate grid. So again, rotations equal spin, and sometimes you might even hear us call them turns. So if you hear turn, spin, or rotate, those are all talking about the same thing. And this is section 2.4. Okay, now again, if you don't have 3 note cards this time, I'm going to ask you guys to pause the video and go talk to either Miss Stevens or Mrs. Litzel to get some note cards. Again, you need 3 this time. Okay, so yesterday you guys did this activity where you rotated a rectangle around the origin and you had to fill out a piece of paper on how the coordinates changed. I believe this was probably the hardest activity you've done in transformations so far, but in my opinion, it's also the most fun. So we're going to get your guys' note cards filled out. So we're going to start here, and this is for when you're doing a clockwise rotation, so the direction a clock would go, and you're going 90 degrees. So that's only 1 turn. Okay, so this is going on the front. If you need to pause to give yourself enough time to write that down, go ahead, but I am going to keep going. On the back, you're going to write down the steps for what to do to your coordinates. So step 1 is you guys are going to switch the X and the Y coordinates. So they actually switch places. It's not them becoming opposite, they switch places. So you might even want to write switch places. Then step 2, you take the second number and make it opposite. So here's my original. I started out with 2, 3. I switched their locations, so the 3 and the 2 switched places, and then I made the second number opposite. Mrs. Litzel came up with this really cool way to remember which number to make opposite. So if this doesn't make sense, definitely call her over and have her show you this. So if you were to point clockwise, the direction a clock goes, we would point this direction, which also points to the number we make negative. So to point clockwise, we go this direction and it points to our second number. Okay, if you need to pause that, go ahead and do so. I'm moving on. Okay, the next one is if we do a 90 degrees counterclockwise rotation. So it's still only 1 turn, but now it's kind of like we're spinning backwards. Just so you guys know, 90 degrees counterclockwise is the same thing as a 270 degrees clockwise rotation. So you should probably go ahead and write this on the front of your note card as well. And I know my handwriting is not great. I'm writing this with my mouse right now. Okay, pause if you need to. On the back, you still switch your X and Y. So anytime you see a 90-degree rotation, you know the X and the Y are switching places. So that's our first step. But the difference between a counterclockwise and a clockwise is which one we make opposite. So when it's counterclockwise, we make the first number opposite. So here's an example. I started out with 1, 4. I switched the places of the 4 and the 1. And then if I point counterclockwise, the opposite direction that a clock goes, I find myself pointing to the first number, and that's the one I make opposite. Again, if me with the arrows doesn't make sense, call Miss Litzel over and she'll show you with her hands how to use this very helpful tool. Okay, so there's 2 of our 3 note cards. Again, pause if you need to. Now we've got our final one, and this is the easier of the rotations because there's only 1 step when changing your coordinates. So first of all, label this as a 180-degree rotation. And on the back, the only thing we have to do this time is make our X and Y opposite. So there's no switching places. Here's our original, and we go to the new one, the prime, or the image is going to have the coordinates both opposite, but no switching places this time. I know this is hard to remember, which means it's going to take a lot of effort on your guys' part to practice and study so that you can remember these rules. Okay, so now we're going to practice. Again, when doing this, the first thing we always want to do is list the coordinates of the original, there's no R, of the original coordinates, okay, or of the original figure. So that kind of looks like a C to me. So the T is 0, -3. The Q is 4, -3. And the C is negative, oops, nope, not negative, sorry, is 0, -5. Okay, now it's really important here is the direction. So I see 180-degree rotation, and I feel a sense of relief because I think this is the easier of the rotations. So now I'm going to rewrite, oops, forgot my apostrophes. So now I'm going to write my new coordinates, and I can go back a slide here and look at my rule. So when it's 180-degree rotation, I just make the x and y's opposite. So I can't make 0 opposites, which just stays 0. -3 becomes 3. 4 becomes -4. -3 becomes 3. Can't change 0. And -5 becomes 5. Now, I only have 10 minutes on this video, so I can't really spend a whole lot of time graphing, but I will graph this one just so we can see that it's right. So I got 0, 3, -4, 3, and 0, 5. So this one's a little harder to imagine. You guys, with your brains aren't fully prepared for this yet, but you can kind of think if you spin it once, it would be kind of up and down here, and then it would be sideways again up here. Okay, next one. So now we've got a 90 degrees clockwise rotation. So again, let's list our originals. I'm probably not going to graph the new image here just because I only have 10 minutes on the video. So I've got -1, 5. S, I've got -3, 3. And I've got 2, 1. Okay, so now I need the new ones, the image, the primes. And I'm going to need to flip to, now you guys can just flip to your note card. I don't have my note cards in front of me, so I'm going to flip back a couple slides and see that a 90 degrees clockwise rotation means I switch the numbers, switch their places, and then make the second number opposite. Okay, so that means the 5 and the -1 would switch places. So this would become a 5. A -1 goes here, but then this becomes opposite, so I make it a positive. Here they switch places, so my 3 and -3 switch places, but my second number becomes opposite, so it becomes a positive. My 1 and my 2 switch places, but my second number becomes opposite, so it becomes negative. Again, I'm doing a clockwise spin, so I'm pointing to the second number. Now we've got a 270 degrees clockwise rotation. So that means I'm spinning 1, 2, 3, which to be honest is the same as a 90 degrees counterclockwise rotation. So those are the rules we're going to use here. So E, G, Q, L. So E, I've got 1, 5. G is 2, 4. Q is, 3, 2, and L is -1, 2. So now I'm going to do my new ones. Always start out with your originals. It makes your life so much easier. Don't make your life hard by skipping steps. For some reason, I'm having trouble writing with my pen over here, so it's not looking the prettiest. Hopefully you guys can figure out what I'm doing here. Okay, now again, you guys can just look at your note card, but I have to go back a couple slides. So at 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So I'm going to switch my X and my Y and then make my first one opposite. Okay, so E was a 5 and a 1, so I'm going to switch. Make opposite. Guys, I only have about 30 seconds left in this recording, so I'm not going to get all the way through this example. But if you guys need further assistance, Miss Litzel is here, and you guys can also look at your book to get help. I'm going to keep going until my time cuts off. So I switch my numbers, and my first one becomes opposite. I switch my numbers, and my first one becomes opposite. I switch my numbers, and my first one becomes opposite. If we graph it, it should show up